All right, so I think it's time to kick off the session. Hello, everyone. Good morning. My name is Hong, and I work at Databricks as a solution architect. So I'm actually based in Germany, and still trying to dealing with my jet lag, but super happy to be here. This is also, for me personally, the very first DICE event that I've been participating with. So today, I have the honor to welcome you and then give a short introduction to our speakers here from Capital One Software. So I'm with Yutish and Laura, and today I think they are going to show us how to manage the high quality secure data and also manage cost visibility for AI, which I think is super relevant and an interesting topic for you. So thanks for coming. And with that, I'm going to hand it over now to Yutish and Laura to the stage.
Hey, good morning, everyone. Welcome. I am Yutish Batra. I'm a distinguished engineer at Capital One Software, and I lead the architecture for our product, Capital One Slingshot.
And I'm Laura Case, Director of Product, the product lead for Datavolt Partnerships. So let's just dive into today's agenda. First, we're going to tell you a little bit about Capital One and our tech transformation. Then we're going to talk about the main focus of our presentation today, data principles for AI. We're going to talk about how to manage high quality data that's trustworthy. Then we're going to discuss how to secure data for it to be AI ready. And then once you're ready to build and deploy AI models, how do you ensure you do this cost efficiently? And at the end, we'll wrap up with some key takeaways. So you may know Capital One as a bank, but we are actually a technology company. We've undergone a dramatic tech transformation to operate with the speed and agility required to succeed in the digital age. In 2016, we declared that we were going to be all in on the cloud to allow us to harness the power of all of the massive amounts of data that we've collected. In 2017, we had to start re-architecting our entire data ecosystem on the cloud in order to manage data and AI at a larger scale to create our foundation for AI analytics and machine learning. With this, we started to adopt cloud technologies such as Databricks. And in 2018, we assessed very different security solutions to be able to protect our data in the cloud. And we found that there wasn't a solution on the market that would meet the scalability and performance needs of our organization. So we started to build our own in-house tokenization solution. As of 2020, we shut down our last on-prem data center and had moved all of our data to the cloud. And along that journey, we learned a lot of lessons about how to manage data at scale in the cloud. And with that, one of the things that we developed internally was a way to manage our costs. And as we worked on this product called Slingshot, we realized that other enterprises could take advantage of our lessons on how to more effectively manage the costs of their data. And so we launched Capital One Software. And Capital One Software is a B2B enterprise business within Capital One that takes products that we've built internally for our own needs and commercializes those. And then 2 months ago, we announced the latest product, which is a commercialized version of our tokenization solution, also known as Databolt. Along our journey, we've learned that high quality and well-managed data powers our ability to build proprietary AI tools. Some examples are here of different tools that we've built. The first is Chat Concierge. This is a multi-agentic AI solution that connects car buyers and car sellers to one another to improve the car buying experience on both sides. It also takes action on customers' behalf based on the requests that they make through the tool. We've also developed our own in-house Gen AI-driven agent servicing product. This allows our thousands of agents to efficiently and effectively manage our customers' relationships when they need to connect with our customer service lines. And then lastly, we harness the power of our data to provide AI-driven personalization to improve our products. This proprietary AI system enables rapid experimentation and iteration for our 100 million customers. Our use of these AI tools creates a flywheel that drives increased customer engagement. Our application of AI powers exceptional customer experiences, which in turn enhances customer engagement and interactions with us. Customer engagement provides insights into how satisfying the experiences are, and also opportunities for us to improve them. And then these insights lead to more engagement and continued refinements of the experiences we provide. Through this flywheel, we apply even more customized real-time solutions to unlock impact for our customers and for the business. Now, research shows that there are 3 common barriers to adopting AI in data management. The first, trusted data, is a top hurdle to implementing AI. Data is everywhere, growing rapidly. How do we find the data we need and trust that data when it's put into a model? And then second, data and data security hinder adoption. Customers trust us with their sensitive data, and we want to make sure models or chatbots aren't going to leak any of that information. And then lastly, cost. It can be incredibly expensive to build and maintain models. So how do we reduce the cost barrier to get more value out of the data? At Capital One, we face these same challenges in our journey to adopt AI, and our presentation today will focus on each of these pillars. First, how do we get to trusted data? Second, how do we secure data in an ever-growing data landscape? And then last, how can we be cost efficient and get as much value out of our data as possible? Now, the biggest lesson that we've learned in our journey is that world-class AI starts with world-class data. I've been in the data and analytics space for a couple of decades, and we've said this very differently with our data teams, which is garbage in, garbage out. Your analytics, machine learning, your AI is only as good as the data that you feed into it. Having strong fundamentals and a commitment to a strong data foundation is the baseline for AI readiness. And we learned some best practices on how to turn that phrase around and to get to good AI. So let's dig into what that means. First, we want to talk about how to manage high-quality data, also what we call trusted data. Trusted data is the foundation to ensuring data is ready to use for AI use cases. Our experience has shown that there are foundational pieces you need for data to be AI ready. First, you need high-quality metadata. You need to understand what data you have feeding into your models, and that requires understanding a lot more about your metadata. And then you also need high-quality data. Again, we're trying to avoid garbage in, garbage out. And then the last thing you need is end-to-end lineage. We're going to drill a little bit deeper into each of these so that we're all working with a common understanding of what we mean. So, high-quality metadata, what do we mean? What we mean is, first, where is the data? Is it in Databricks? Is it in shared drives? Is it stored on somebody's laptop? Do we have it in S3 buckets? We really need a solid inventory of where that data lives that you want to feed into models. And it's even better if you have an inventory of everywhere you store data across your data landscape. And then once we know where the data is, we need more details about that data. What is the database schema, table, column? Do you have any data classification of it? What type of data is it? And then do we have any policies around that data, its usage and its storage? Is it protected health information? Is it PII? Are there any regulations around using that data? Having really good quality metadata lets you pick the best data available for your AI models. And then once we know where our data is, we want to know how good the data is. And again, all of this in the avoiding the garbage in, garbage out. Data quality assessments can be done in multiple ways. So some options are to scan the data, either manually or automatically. You can also use data profiling, data quality tools. There are many different methods to assess the quality of your data. And then sometimes the data comes to you in a trusted format, such as data sets you purchase, or maybe you have an internal system with trusted data, such as your master data management system, that is coming to you that you know the quality of that data. And then lastly, data lineage. So data has a life cycle. Very rarely do you see data come in and have it not change at all. So first, data can change over time. Simple example, like myself, my date of birth has never changed. However, I do have twin teenagers, and in their teens, my hair very quickly moved from brown to gray. And then obviously over time as well, my address has changed, moved to a slightly larger house with a growing family. Data also changes as it moves from system to system. So you may ingest the data and then you run some type of transforming processes on it. Or like we mentioned before, you're running data quality checks and fixing that data and resolving some data issues. And so really understanding your data at every step in its life cycle is critical to understand what data you're feeding into your model. And then when choosing your data, you really want to make sure that you're choosing the right data for your use case. And all of this requires a fundamental understanding of the lineage of that data. Now, once you have a solid foundation of high quality metadata, it's time to secure that data. So there are many different ways that you can protect data. So the first three on this screen are really about non-reversible forms, and then we also have reversible forms. So let's just talk about each of these. And a lot of these lessons are lessons learned from our own data journey. And this is an overall spectrum. So the first piece is deletion. So if you don't need that data, you're paying to store it, you're paying to process it, you're paying to have people on your team look at it. First, basically deleting data that you don't need is really the first way to protect it, but obviously if you delete data, that's not going to be usable for all of your AI models. And then masking data. So masking is where you convert this into another format, such as using 9x's for a social security number, or using the first 6 to mask your social security number. Again, this is a valuable way to protect your data, but largely leaves it unusable for models. And then redaction, which largely applies to unstructured data, is another way to protect data. So then we get into the two options that actually allow you to reverse them, which is encryption and tokenization. People generally are more familiar with encryption, and so we wanted to talk a little bit about tokenization, how that works, and specifically API-based tokenization. So at the core, both encryption and tokenization use cryptographic methods to convert clear text to ciphertext. Encryption requires a key called a data encryption key to decrypt or to encrypt and possibly decrypt the data. So API-based tokenization, which is what we use at Capital One, the way that it works is that an application receives some type of sensitive data, then they send a request to convert the data from clear text to ciphertext, and then the tokenization layer receives the API permissions, and if approved, sends the token back to the application so the application can store the token. And then the reverse is also true if the application has the ability to de-tokenize the data. Now, as I mentioned, during our data protection journey, Capital One chose tokenization, and we chose this for a few different reasons. First, tokenization requires less key management than encryption. It also protects against brute force compromise. Second, tokens can have embedded metadata that allow for bad token detection, as well as help when the tokens need to be rotated. Tokens can also be format preserving, and so the data can be tokenized, and then we can continue to use it without modifying the underlying schema or the applications that use it. And then most importantly, tokenization allows for the utilization of that data when it's tokenized, allowing us to still get full value out of our tokenized data in analytics and AI use cases. So Capital One tokenizes our data at scale. Along the way, we've learned some best practices in data protection. You'll notice that these best practices are very familiar as we walk through what we've learned. First, we learned that having high quality metadata is key. If you want to protect data at scale, you need to know what data you have and where it is. And to be able to tokenize at scale, we need an inventory of what data we have. And we use scanning tools to scan all of our data. The next best practice we learned is that we need to understand the policies that are applied to data. We're in a regulated industry, so we needed to comply with many different regulations. We also considered whether we could use any of the previously mentioned data protection methods. Was there any data that we could delete? Could we use masking? Could we use redaction? What data do we need to be able to use? The next best practice that we learned is that we need to understand the policies that apply to that data. I think this might be a repeat, or we're frozen. Unable. All right, perfect. So once we got to the point where we wanted to protect our data, we found that there's not a one-size-fits-all solution to this problem. We require that our business implement the highest road that is technically possible for their use case. With structured data, we have a lot more options, and tokenization is our preferred method for structured data. With unstructured data, much of this flexibility is removed, and encryption becomes the preferred method of protecting sensitive data. Our next best practice is that we recommend to use robust data access controls. We leverage cloud-native features for data access control. We use identity and access management, which allow for the granular definition of permissions at the user group and role level, ensuring that access to data is appropriately restricted to authorized users. And we rely on the native functionality of AWS's access control features paired with our custom access policies within our tokenization solution to lead to more scalable, performant, and secure operations. And our last best practice is that data protection is never done. It is a continuous process. For us, data protection involves continuously improving our process of scanning data, optimizing the efficiency of our tools, scanning newly acquired data, and refining our data ingestion and tokenization process. Now, with all of these learnings, that brings me back to Capital One software. So we recently announced the launch of our tokenization solution, DataVault. Our solution offers a few features. Our security model ensures that sensitive data never leaves the customer's environment. Our cloud-native architecture offers a flexible deployment model that can fit a customer's unique infrastructure. And we offer lightning-fast performance with a throughput of up to 4 million tokens per second. Now, you're all at a Databricks conference, so let's talk about Capital One DataVault for Databricks. So we also seamlessly integrate with Databricks to offer customers high performance and convenience while securing their data. We integrate with Unity Catalog, Databricks Workflows, and Databricks Role-Based Access Control, as well as Databricks user-defined functions to provide an end-to-end tokenization solution. We leverage Unity Catalog metadata information and Databricks Workflows to allow customers to choose what data to tokenize and to facilitate simple tokenization. Customers deploy the tokenization engine directly in their environment to decrease latency, and tokenization functionality is accessed through UDFs that are simple to interact with and set up automatically during installation. And we leverage Databricks user groups to configure Databricks RBAC, allowing users to tokenize and de-tokenize data. Now that we've protected the data, the next practice is to manage your costs.
Thank you, Laura. Now that we have seen how to build high quality, secure data and spend more money, let me go back and save some money. So we'll share some best practices on how we can build a cost-effective data ecosystem. But before we get into the how part, let's talk about the what. Like what is the total cost of ownership in today's world of data and AI and the options that we are getting. The total cost of ownership is changing and evolving. So let's talk about that. The first and foremost is the cost of data. And this is further divided into 3 different categories. So data management infrastructure, and what do I mean by that is it's any tooling that you leverage with your data ecosystem. It could be maybe ingestion tools, scheduling tools that you leverage in the data ecosystem. Second is the data preparation and engineering cost. So as Laura spoke about building high quality, secure data, all that cost will be in this bucket, which is basically how you are preparing your data, getting your data ready for AI and consumption by the analyst and securing it. And last but not the least is the storage cost. This is the actual storage cost for the data that you pay to the cloud providers. It could be small right now, but as the amount of data is growing, it could really balloon very quickly. So we got to keep eye on what is used, how much is used, and can we delete it, and kind of keep a check on the cost. The next is the compute cost. This usually would be the major chunk of cost that you will incur in your data ecosystem. And it includes the cloud infrastructure, which is basically any compute that you are provisioning for processing your data. In Databricks, it could be the job compute, APC, and if we look at the AI tech infrastructure, so as we have new models coming in, we are building models, training, fine-tuning them. Any sort of GPU that is leveraged would fall in this category of AI tech infrastructure. The next is the model build cost. So this is basically if you decide to train your own model, own base model, you would incur a heavy upfront cost of training the model. But if you want to leverage a model that is available out of the box in the market, then you would have some cost in fine-tuning the model, basically training the model with your data so that you can answer specific questions about your business. The next is, and last is the model operations. This is basically once you have the model ready, I want to serve the model to the customers. So all the cost that is incurred in serving the model is in this bucket as well. We have the model monitoring, which basically keeps a check on the model to see if there is any bias or if there is any degradation in the performance of the model. So now that we understand the total cost of ownership, let's look at key areas which we need to invest in early to make the most out of our data. So first is the governance, and what do I mean by governance is that we need to put the right controls, checks and balances in the data ecosystem to make sure it is utilized properly, there is no abuse, there is no over-provision compute, and there are controls and checks in place where the data platform owners can feel confident in scaling the use of the data platform across the organization. The next and the key is optimized compute. So as I said, compute is a major chunk of cost. So you want to make sure that you have the right size compute at the right time for the jobs. And the last is the monitoring and observability. Having right monitors, right controls in place will make sure there is no wastage in the system and you are proactive in responding to issues. So let's dive into each of these categories. First is building a well-governed data environment. So at Capital One, we adopted the cloud data warehouse technology early, and there were very few tools that were available in the market, and we decided to build something for our own. And we have a lot of lines of business in Capital One which leverage these tools, and then there is a central team which manages the data ecosystem. So we decided to go with a federated ownership model where we have controls defined by the central team, whereas lines of business are kind of always within those boundaries and using. So we chose the federated ownership model. Next is defining the budgets. Having the right cost controls was the key to make sure that we don't overrun our budgets, our allocated money to the data platforms. And last in this was having the reviews and approvals, having the ownership defined, and getting the right approvals before allocating the money to a particular use case. Now this is how we did the federated ownership and the governance, the hierarchical governance. So if you look at the bottom, we have a group of compute owners which are responsible for certain projects. They belong to a business unit, let's say an analytics team, and then in a business unit of data engineering. So we have admins in this group which are responsible for their own organization, their own project teams. They have their own defined guardrails. And then on the top sits the platform admins which have defined the overall governance for the data platform, and they are responsible for managing the entire data ecosystem in our organization. So this is how we implemented the hierarchical governance in Capital One to federate and scale our data usage across the organization. And we are Capital One software, so we kind of packaged that solution which was built internally, and it's available as Capital One Slingshot. So you can configure it for your own business. You can choose how you want to use the approval system, how you want to use the controls in the system, and you should be able to leverage it for your own company. So, and we recently launched it for Databricks as well. So we support Databricks within Capital One Slingshot now. Next is optimizing the compute infrastructure. So the first and foremost in optimizing your compute infrastructure is the compute specific settings, like what type of compute do you want to leverage. You need to pick the right size, right type of the compute for your workload. So if you are running analytics queries, you might want to choose a SQL warehouse that is available. If you are running jobs, the job cluster is the right compute instead of APC. So that's another key thing that we have to keep in mind, that we pick the right size, right type compute for the workloads to get the maximum value. And the last is leveraging the platform features that are provided by all the providers. So in Databricks, they have GPUs available and other features which Databricks provides. So now moving on, again, in Slingshot, we have built a job optimization solution, which basically makes sure that your job cluster is always fit for your workload and it is meeting the SLA. So this is available in our product, and it is basically an ML-based solution where it continuously monitors your jobs and right sizes your compute for your jobs and saves you money. Next is implementing monitoring and observability. Strong foundation requires monitoring in multiple aspects. We need to monitor multiple aspects of the data ecosystem, and the first is monitoring the data pipelines. So as your data pipelines are running, you want to make sure that they are healthy, they are not failing, and if there are failures, somebody is alerted. This would ensure that the data arrives timely, the data available to the downstream models is accurate, and the business insights that you're deriving from the models are correct. The next is the data quality checks. As Laura mentioned, we need to monitor for, we need to have data quality checks in place, plus we need to monitor that the data quality checks are passing as they go along. If there are failures, somebody is actioning on the failures and making sure that the issues are fixed in a timely manner. And the last is the cost visibility by workloads. So Laura touched on the data lineage piece, which is basically how the data is flowing through the ecosystem. We also want to keep track of cost by workloads so that we can derive the return on investment. So let's say you're building a pipeline, the data flows through multiple steps, it gets transformed and finally gets used in a BI report or in an AI model. We want to have the visibility of cost across the workloads, just like lineage, so that we can capture what's the cost of this data and how it is benefiting the business. And with all that, it should be done proactively. It should not be reactive. With proactive, you can make sure that your data is accurate, timely, and the insights that are generated from that are good and have good impact on the business. Now, getting these things right is the key to deploying and building AI models. And we want to leave you with 3 key takeaways, which is trusted data is the key to good AI. And data security is a continuous process. You got to keep monitoring your data to make sure it is secure. And last is cost governance should not be an afterthought, which is you want to invest early in making sure you have the right controls before you scale your data ecosystem across the organization. All right, that's it. Thank you so much for taking the time. And you can visit us at the booth E412. You can check out both our products, Data Bolt and Slingshot. Thank you.